All right, good morning, everyone. Today is Tuesday, November the 16th. We are on our very last lesson of unit number 4, which is our last unit of the semester. After today, we just have reviews and the test for unit 4, and then the review for the final, and then that test. And then we're done for the year. Well, 2021, and we'll be back in January for second semester. All right, so we did this problem yesterday. So I'm just going to show the answer in the work. Maybe a lot of you reworked it out, but hopefully got the same thing. Negative 2.521. It does say, oh, I meant to change it. It says round to the nearest 10,000th in the directions. I actually meant to change that to the nearest thousandth. Not that it made anything different. I wasn't trying to trick anybody. Let me just pretend. Let's do that, and it was like it was never there. Okay, so get out your paper, pencil, pen, calculator, all that fun stuff like we had yesterday. We're gonna do some more solving of log equations. Um, More specifically, towards the end of this lesson, we'll be doing word problems involving radioactive decay and exponential growth. But before we do that stuff, we're going to still solve problems like yesterday. I think this was in yesterday's learn and practice module, and we just didn't have time to get to it. So I'm going to get to it now. All right. So all this says that is if log base b of x is equal to log base b of y, you can think of this equation here to clear your log base b. You would just base b both sides here, and then those would cancel out, and we would just have x equals y. So this little formula here, this little theorem, if you will, is just saying that when you have log base b of stuff equals the same log base b of different stuff, or it could be the same stuff, all you have to do is just take that stuff, in this case the x and the y, and set it equal to each other and solve. And I think at this point in this unit 4, this should make perfect sense, and in a way goes without saying, because we all know that we could have just base b both sides. Everyone, so far so good? All right, nothing new. But we're going to still try to use this to solve the problems that I have on the next few pages here. So our goal here when we solve these equations is we want to have a log on one side equals a log on the other. And we want this base b to be the same, of course, which they will be. So let's use our properties to accomplish that. So let's do this first one together, maybe the first two. So we have log base 4 of stuff minus log base 4 of stuff equals log base 4 of some other stuff. So right now we have we have 3 terms. So what we want to try to do is get one term on each side. So log of stuff equals log of some other stuff. Now, using the properties that we have learned, what looks easy to you? Not what's just obvious right now looking at us, but what do you think is going to be an easy approach to get a log on one side and log on the other side using our properties? So subtraction becomes division. That is one way to do it, absolutely. So we can collapse this log of stuff minus log of stuff into a single log, correct? Yeah. So that's one way to do it. We have a different way that might be easier. Hang on a second, sorry. Close my lesson. I had opened my other screen by accident. One moment, sorry. Say since all the bases are the same, we can set everything after the log. Um, well, okay, so Naomi, not yet. Um, because we have, even though they're all the same, um, we can only do that as if we are in this form here. Log of something equals log of something. Right now we have too many logs. Maybe you actually said something before that. All right, so yes, we can make this into division. Um, let's go ahead and do that. Everyone, contract this into a single log. Okay. Everyone agree with what I wrote? Yep. And now can we set that fraction x minus 7 over 8 equal to 6? We sure can. So let's go ahead and do that. All right, everyone go ahead and solve for x now. Give me a green check when you have done that. Oh, all right, what did everyone get? 55. Yeah, that sounds right. And could we plug 55 into x right here and just see if the left side equals the right side? Absolutely. Yeah, we would just type in 55 here, and then we go to our nifty calculators, and we would type in the left side, hit enter, and then we would type in the right side, hit enter, and we compare to see if the left side equals the right side. So great way to check our answer. To solve this, multiply both sides by 8, and then add 7. I do want to show this problem a little differently. So when I look at these problems and I see a minus sign here, I personally try to avoid fractions. So instead of subtract this, could I do something with this term? Yeah, I could add it to both sides. I could totally add it to both sides. Does everyone see that? And what does addition become when you're trying to contract? Yeah, it becomes multiplication. So we get 6 times 8 is 48. And now can I set the x minus 7 equal to 48? Yep. And we can see the problem it's just a little easier to look at because we don't have fractions, and then our only step after that is to add 7 to both sides. But either way works. We could do it like this, or we can do it like this. It really doesn't matter. I'm gonna try. So the rest of the examples that we have, I do my best to avoid fractions if we can, and I think on every problem there is a way to do it. You just got to kind of think about it. All right. So this next problem here, again, remember our goal is to get just like. Let me go to this next page. Our goal is to get log of stuff equals log of stuff. So that's what we're trying to do today to solve these. And by the way, there's obviously more than one way to approach these problems. I'm just giving you more tools for your toolbox, and you can kind of decide on how you want to do it. But So we want to get log of stuff equals log of stuff. So right now we have three terms: this term, and then this term. Ideas. Can we do? Ooh, Noah. Very good. Yeah, I like what Noah's thinking. Noah's saying that because we need to have everything to have the same log base 3, every term needs to have that. And this constant, this number right here, this 1 does not. But Noah's saying that we can just rewrite this as log base 3 of 3. So yeah, for on the right, that 1, this right here, I can rewrite as log base 3 of 3. Isn't that the same thing as 1, just written differently? Yeah, you guys are so smart. And then looks like someone else said we can also add that negative log base 3 of 5 to both sides. So yeah, I'm gonna do that, and that 1 we're gonna rewrite as log base 3 of 3, like we already talked about. And then addition becomes multiplication. So we get, what's 3 times 5? I forget. 15? I think that's right. 15. Now can we set x minus 10 equal to 15? Yeah. Yeah, and we just solve, right? Nothing too complicated. So really, as long as you understand that we can change like 1 to log base 3 of 3, and let's say, for example, um, let me what if I had like stuff and then it equals like, I don't know, 5? So instead of equaling a 1, how can I deal with that? Any ideas? So it's going to be similar to what we did when it was a 1. Very similar. So let me ask you this. Off to the side here. Is 5 the same thing as saying 5 times 1? Is that still a 5? Yep, sure is. So what do you think? Based on that clue, what do you think I need to do? It's going to be like a two-parter little step. Remember, every term needs to have the log base 3. There we go. Yeah, 5 times log base 3 of 3. So we just basically tack on log base 3 of 3 after this. And then what do we do? Yeah, then we move that coefficient, that 5, we bring this to become an exponent of that 3 using that log property. So now we change that 5 into a term that has our log base 3, which is what we need. And then if you wanted to, you can do, well, we would have to. We would do 3 to the 5th power, some really big number. I don't know. So yeah, as long as you understand that, and changing a 1 to log base 3 of 3, if that was a number other than 1, we would have to basically just stick a log base 3 of 3 in this situation here to it, and then move the coefficient to become an exponent. And if you wanted to type in log base 3 of whatever this number is in your calculator and hit enter, it'll get you back to, in this case, 5. Yeah, we're just doing some clever manipulation of the way the equation looks, but not remember, we don't change the value of it, we just change the way it looks. We dress it up. All right. So with hey, look at that. There's a 3 here. Maybe we can um, deal with that like we just talked about. All right, everyone try this one here. And give me a green check when you finish this first one on the left. Yeah, ready to go. By the way, your answer for the first one will be a fraction. Make sure you reduce it. Remember, if you can avoid contracting logs to become fractions, if you can avoid doing that, it's easier to kind of add stuff to both sides or whatever to make your contraction of logs multiplication instead of division. It would help if I turn my mic back on. All right, what did everyone get? X equals what? Negative 143 over 18. Anybody else? Same thing? Okay. Yeah, that sounds right. Let me just uncover the very bottom and see what's going on. Yeah, negative 143 over 18. That's correct. All right, what did everyone do for their first step? It's okay if you use division. That is quite okay. If you're somebody that is okay with fractions and setting that up and then solving them, that is okay. I I personally would probably do the same thing if I was just like making an answer key, or if I was in your shoes. I would just make the fraction as well. So, you can make it into a division, or we can just add the log base 7 of the x plus 8 to both sides. Only doing that just to avoid creating a fraction. And then addition becomes multiplication. So we get log base 2 on the left, sorry, log base 7 of 2 on the left, and then log base 7 of 36 times x plus 8. And if you wanted to distribute that 36 to the x and the 8, you can. Um, I don't, just because when I set them equal to each other, what we're going to do. Oh, actually, no, I did distribute. Okay. There was a way to, I guess, not do that and just divide everything by 36 and then create fractions early on. Um, Either way. So it looks like when I typed this up last night, I distributed it. All right, next from here, it's super easy, right? We just subtract 288 from both sides and then divide everything by 36. So nothing difficult. The hardest part about this problem is getting from multiple terms, more than two, to a single term on the left, log of single term, and then log single term on the right. Um, that should be the hardest part of these problems. Once you get to here, setting them equal to each other and solving should be piece of cake. Okay, on the right, everyone work on that problem. Give me a green check when you are finished. Your answer will also be a fraction for this one. And when we go through these, if you do want to see the problem done a different way, because I'm obviously, as I told you before, I'm going to avoid fractions. But if you want to see it done that way, just let me know and I can handwrite it. If you want to know, or tried it that way and just couldn't get to the same answer. Naomi, are you here? Still working? Just want to make sure you didn't walk away. Okay. Back in. All right, what did everyone get for this one? 5/8, 5/26. What else? 5/2, 5/26. All right, so let's take a look. The answer is, at least the answer that I got was 5/26. But it's possible that maybe I typed it wrong too. We'll find out. We'll find out. So I move that log base 3 of x to the other side by adding it, and then that 3. What did all of you change that 3 to? So 3 times log base 3 of 3. Everyone agree with that? Okay. Hopefully nobody tried to jump to the simplified form of it. So yeah, we have to take that 3 and multiply it times 1, which is, well, log base 3 of 3 is 1. And then you have to move that 3 to the exponent of that, well, that 3. All right, is 3 cubed equal to 9? Yeah, it's not. Yeah, 3 cubed is 27. So my guess is if you made a mistake, it was probably right there. You somewhere along these steps here, going from here to here, that's probably where the mistake was. Anybody want to admit that? Yep. Okay. Yeah. Yeah. That's, well, it happens. I only know that is because it happens apparently a lot. All right, and then multiplication, or sorry, addition becomes multiplication. So you have 27 times x on the right hand side, and then we can set the log of that stuff equal to each other. So x plus 5 equals 27x, and then from there, subtract. Sorry, subtract x both sides, and then divide by 26, and that's how we get x equals to be 5/26. Mm-hmm, mm-hmm. Any questions on this one? Those couple people that did miss it, you found your mistake, I hope. 9 instead of 27. Yep. Yep. I believe it. Here's the work I did for making it. Wait, is that the first one on the first page? It was. Okay. So the first problem on this page, I did it again without moving it to the other side, and I just made it into a fraction. I'm just going to show that real quick if you're curious. So we have this fraction equals this, and then we just cross multiply. We have 36 times x plus 8 equals this 2 times the 1 here, and then distribute and then solve accordingly. I want to show it this way, just if you're curious and didn't do that work. All right, we're gonna skip these two problems. Go ahead. Well, you should have downloaded the guided notes for this, but Make sure you come back at the end and work on these just because it's good practice. And let me go ahead and just show you the work for both of these. And one thing I want to note that don't forget whenever you square root both sides, don't forget plus or minus. And then if you want, and then for best practices, we should probably plug both numbers back in to make sure it works. But at quick glance, squaring a negative or squaring a positive yields the same number. So I can just see without even finishing the check, I know they're both going to work. Same thing for over here. If x was positive or negative, when you square it, it makes it positive. So we're going to have two answers for this one too, and plus and minus, and they're both going to work. Oh, by the way, so here's a question. So we know that addition becomes multiplication, right? So we want the left side natural log, we want it to equal 40, right? So this becomes multiplication. So 8 times what gives us 40? We're going to mental math this problem. 8 times what? Yeah, 5. 8 times 5 is 40. So we know that this piece right here needs to equal 5. All right, we already got 4. 4 plus how many more do we need? 4 plus 1 more. So if we only need 1 more, what does x have to equal? Yeah, 1 or negative 1. Yeah, so we totally mental math that one. And then there's the math just to prove it. But please work on this and then look at the work and the answer to make sure you get it right just by doing it by hand. Not you can't always mental math these, but if you kind of look at them and observe what is happening and how we know that addition of log and natural log becomes multiplication, we know it needs to equal 40. We might be able to figure it out without really doing any work on paper. So, food for thought, right? Food for thought. All right, let's get to, oh, and then this is another way to do this problem. What did I do with this one? How's that any different? Is that any different than what I did before? Oh, yeah, okay. So look at it. So on here, I actually made it subtraction because I saw that I recognized that 40 divided by 8 is 5. So I went ahead and I subtracted natural log 8 for my first step. And then subtraction became division. So 40 divided by 8 gave me 5. So I did it that way. Um, I don't know. I would say this is probably kind of a weird way of thinking of it because doing it this way and seeing it multiplication probably makes more sense. And then it looks like when I set them equal, I didn't distribute this 8. I just divided both sides by 8. And 40 divided by 8 gives me 5. And then this side divided by 8 just makes it go away. So, guys, there's more than one way to approach these problems. So whatever speaks to you. All right. All right, now let's get to the other half. Okay, I wanted to start at 9, but it's 6 after. All right, the actual fun stuff of today's lesson: radioactive growth and decay. So we have a total of 4 problems. We have 2 for decay. We have 2 for growth. All right, we are going to use this formula. This is the decay formula. Now we do have another decay problem or equation that we learned in 4.0. Was it? Is it 4.02 or 4.04? I forget which one. But this is the one we're going to use for radioactive decay. All right. N is the number, is the amount after some time. N sub 0, this is your initial amounts. E is a constant. There's a key on your calculator that says E. K is some constant that we have to figure out. And then T is your time. Yeah, K is some constant. All right. The beauty about these problems is every problem, no matter if it's radioactive growth or decay, they're done the same way. So if you understand what we're doing for one problem, you should be able to do any problem, any situation. By the way, do you guys see these blue boxes on top of this red? Do you guys see that? Yeah, okay, yeah, that's not supposed to be there. It's supposed to be underneath the red. Yeah. Okay, that's weird. They switched the order of my boxes. It's all right. Whatever. Must be a new row feature. All right. The half life of a radioactive substance is the time required for the substance to decay to half its present amount. That is important to understand. Whenever you see the half life, so this unit, half life, is time. Half life is the time it takes from some radioactive substance to go from, I don't know, whatever the quantity is, we'll say 1,000 grams, to half the amount. So half of 1,000 is 500 grams. So half life is the time unit. In your note, you might want to write this: half life is a time unit. For whatever reason, every year I've taught this, students don't understand what half-life is. They don't know the unit, and half-life is time. Again, so half-life is the radioactive substance, is the time required for the substance to decay to half its present amount. We have 11 grams of radioactive substance, decays to just 3 grams in 10 hours. What is the half-life of the substance? Round your answer to the nearest hundredth. Now, this problem looks, well, right now it probably looks impossible. Every problem that we do that involves radioactive decay or exponential growth, it's a two-part problem. You're always going to do a part one, and then you're going to do a part two. Part one, you are always solving for your k value. So part one is always solving for k. So every problem that we do, that is our goal in part one, to solve for k. To solve for k, we are going to use what is given to us. So do we know the initial amount? It's 11. It's 11 grams. Do we know a final amount? Yeah, we know 3 grams is the final amount. Now, do we know the time it took to get to that final amount? 10 hours. Yeah. So again, part one, we're using the givens to solve for k. That's going to be true for every problem that we do. We know we're starting with 11. We know it takes 10 hours to get to 3 grams. Everyone so far so good? Again, these problems look harder than they really are, I promise you. All right, so we just plug them in. Let's plug this stuff into our formula up here to set it up. So far so good? All right, now let's solve for k. What should we do? Divide both sides by 11. Let's do it. Let's divide both sides by 11. That is perfect. So far, so good. Now what do we do? Remember, our goal is to solve for k. Perfect. Natural log both sides. Yep. We're going to natural log both sides. Now what do we do? We're going to move the exponent in front of the natural log. Yep. Now what? Yes, natural log of e, remember, is equal to 1. And if you forget, you just type it in. Natural log of e equals 1. All right, we're almost there. What's next? Divide both sides by 10. All right. So there's our k value. But here's the thing. Remember those 3 rules I told all of you yesterday? What was one of those 3 rules? I gave you 3 rules yesterday, and well, they were all the same. Yeah, never round. Come on, Noah. You didn't write this down. Oh, Naomi, you only give me half of it. Come on. Never round your work. All right, third time the charm. Never round your work. Yeah. No, we're allowed to round our answer because, well, it wants us to in the end. But even though, like, we got the answer for part 1, that is still part of the work that we need to carry over in part 2. So we don't want to round your k value. Now, I meant to look this up yesterday, I totally forgot, but what we can do is we can store this value. Let me see if I can figure this out. You may have to go on YouTube and check out your model, but I'm going to go ahead and let's type this in for right now. We have the natural log on top. We got 3 over 11. And then we have 10 on the bottom. All right, so I get about negative 0.129928 dot dot dot. So what is showing us on the screen? It's rounding it, and we don't want to write that rounded answer for our part 2 work. It could produce a final answer that might be off by, like, I don't know, 1/100th of a point, which would be wrong. So there is a store button on just about every calculator that you can store this answer in memory. And when you do that, it stores the exact answer, not this rounded one that we see on the screen. So where is it on the Casio? Usually a STO. Oh, I see it. It's the key right above the 7. You got to hit shift. Let's see if we can figure this out. Shift, hit that recall button, and then I think we have to type in well, I don't know. I don't remember how to do it on here. Maybe that's it. Maybe that's it. Nope, that wasn't it. Yeah, I don't remember. I don't remember. I'll show you how to deal with it in a minute. I'll have to YouTube that one. Yeah, or if one of you want to multitask and go on YouTube and tell me how to store a value on the Casio FX300, FX115, that'd be awesome. But anyway, let's go to part 2 and we'll worry about the whole K value. All right, so what's our initial value again? 11. And then, so for part 2, the initial amount, so going to be 11, but Part two is to figure out what they want. Now, they want us to find the half-life of this substance. So that is basically the part two question. What is the half-life? So, um, do we know what n is if they want us to find the half-life? So, Rachel says it's 5.5 or 11 over 2. Why is it 5.5? Yeah, because it's half the amount. Half-life is the time it takes to get to half the amount. So our goal when we're trying to figure out what the half-life time is, we're trying to calculate time to figure out how long it takes to get to half the amount. That's half-life. And then we are solving for time. We don't know what that is yet. All right. All right, so we wrote down, we know the starting amount, we know the ending amount, supposed to be half the amount. We know our K value from part one, and then we're trying to solve for T. So we're going to plug everything in. Plug everything in. And you notice my K value is the exact value. I know it seems like a lot to write and kind of annoying. But then, yeah, we just solve for T. So just like before. Oh, and then, by the way, oops, let me do that. Can I undo? Just pretending we didn't see that. Yeah, there we go. Yep, nothing to see here. All right, what do we do next? Yeah, divide both sides by 11. This is going to be pretty much similar. And we got 1/2 because 5.5 divided by 11 is, well, half. All right, now what do we do? Yep, natural log both sides. Mhm. And then move exponent in front. Yep. Now what? Divide both sides by the K value. Yep. What does natural log E become again in this step here? What does that become? It becomes 1. Yeah, we do divide everything by the K. So we have natural log of 1/2 divided by natural log of, basically the K value, right? We got natural log of a fraction divided by a fraction, but there's a fraction within that, and it's kind of a messy to type in. So everyone, to solve for T, I need all of you to type this in. This, again, remember, every problem that we do is going to be done the exact same way. Typing it in is the hard part. At least it should be. This is the hard part because everything needs to be typed in perfectly. Don't forget your parentheses. Don't forget to close your parentheses. Don't forget to have them where you need them. But everyone type this in. And there is a little trick that we can do since I couldn't really figure out on the spot how to store that value into a variable. It's probably really easy. Now it's probably almost there. But what we can do, we can actually type in this K value. So we have natural log of 3 over 11 all over 10. If we type that in, it stores it as our last value. So we would type in the K value first. And then on our calculator, we would type in this. We would do our fraction, then we would do natural log of a half on top. We would close parentheses, and then on the bottom, the Casio has an ANS button. We would do the divide, and then we would hit that ANS button, and that just means whatever the answer was from our previous thing we did, which is type in the K value. Um, doing it that way is probably going to be maybe the easiest. I don't know. It's up to you. Do it both ways and you decide which way you like better. You like typing in everything at once, or do you like typing in the k value, and then once you have the k value typed in, we're just going to do the top divided by a and s. All right, and give me a green check when you have typed this in. All right, what did everyone get? Oh, and by the way, round to the nearest, what does it say? Round to the nearest hundredth. So we got about 5.33 hours. 5.33 hours. Yeah, perfect. That's exactly the answer. Yeah. So there's the long one you should have got, and then that. You'll have a TGA problem of one of these, and some of you, even though I'm telling you right now, never round your work, you round your work, and then on the TGA you round, and then maybe like if you did the k value and you took out the whatever they gave you out to like 10 places and you use that here, you might be okay. But if you round this k value, let's say to like 2 or 3 places, and you use that rounded work here, this answer might be off. You might get like 5.32, or you might even get 5.34. And when I grade, I don't. When I grade, it's not gray. I see black and white. I see you got it right or you got it wrong. And if you put 5.34 or 5.32, I will mark it wrong. I know, not nice, right? Yeah, just don't round your work, people. Yeah, and we should make T-shirts. Just don't round your work, people. We'll quote it and put dashed Rachel. Yeah, Rachel 2K21. Yeah, sometimes, yeah, 0.1 makes all the difference. Exactly. It really does. All right, let's try another one. It took a long time to get through that one problem. Ooh, guys, by the way, we're probably going to go over time again. Sorry in advance. And again, if you have to go to your next class, I record these and you can watch the recording later. Again, my apologies. Or feel free to learn how to do this from the module. The module does, the module presents this in a very different way. And you can decide if you like my approach or the module approach. Most of the time, I think, well, I think I do it easier every time, but some of you may like the way module does it. I don't know. Anyway, let's do this problem together. A radioactive substance has a half-life of 64 hours. If 200 grams of the substance are initially present, how much will remain after 4 days? Round your answer to the nearest hundredth. All right, what do we think here? What are we thinking? All right, so looks like, are we all in agreement starting amount is 200? Yeah, okay. I agree with that. Yeah, starting amount is 200. All right, what else? What else are we thinking? Noah says he thinks that n is 100. Why do you think n is 100, Noah? It's after one half-life. So if you're saying n is 100, what does t equal? 64. Yeah, you are correct. So does anyone else agree with his reasoning that n is 100 and t is 64? You all agree with that? Yeah, I think that sounds right because it does say that it has a half-life of 64 hours. Remember, half-life is a time unit. So all this is saying is that it has a half-life of 64 hours. This means that it takes 64 hours to get to half the amount. Again, it takes 64 hours to get to half the amount. So if we start at 200, half the amount is 100. These word problems, you need to be able to read it and comprehend what the given is. So when I said that every problem is done the same, the math, yes, the math is done the same every single time, steps wise. But in terms of deriving the given, well, it could be very different. Like this presented your starting amount, your ending amount, and the time it took to get to the ending amount differently than this problem. All right, everyone set it up and everyone solve it very quickly. I'll give you a time flies in this class. It really does. Why is it that when we're in math, the whole hour goes by so quick, but after math class, it's like the day drags on? I don't even know. All right, 30-second hit start. Okay, let me just show this work. We divide both sides by 200. We then natural log both sides. We move the stuff in front of the natural log. Natural log e becomes 1, and then we divide both sides by 60/40 to get k value. All right, everyone thrilled with that work? Yep. All right. Next, we are going to, you know what we could also do? Let's see this last problem. Maybe this is obvious, maybe this goes without saying, but we could also rewrite that k value. And I don't know if this is going to be easier or harder to look at, but I could write that 64 out in front to be 1 over 64 natural log 1/2. I could do that, right? For my k value. Yeah, I don't know if it's easier or harder to look at it like that. I really don't know. Yeah, just thought I'd point that out. Right, all right, so we got our k value. And then part 2 is to actually find out what they want us to find. And it says, how much will remain after 4 days? So what's our starting amount again? Yeah, 200. And your starting amount, your n sub 0 is going to be the same for part 1 and part 2. That's just going to be how it is for every problem. All right, and then we know our k value already. All right. Are we solving for n or are we solving for t? Yeah, we're solving for n. Yeah, we don't know what n is. All right, and then what is our t value? You two are so smart today. Well, and every day, but especially today, because you didn't make the mistake of leaving 4 days, well, as days. Because in part one, what was our unit of time? Hours. Because we used hours in our part one, you must use hours in part two. You can't mix units. Hopefully, we all know that by the time we're in pre-calc. So very very good. Yeah. So we have 4 days, and 4 times 24 gives us, well, 96. Excellent, excellent. I thought, well, sure, all of you were gonna say four. All right, so we just plug that stuff into our formula. What's super cool about this part two of this problem? Yeah, all we just need to do is type it in. There's we're solving for n and it's already set up. We just gotta, use our fingers and type it in. So everyone go ahead and type it in and round to the nearest hundredth, it says. And by the way, you can simplify that. I did on the next step, but you don't have to. If you want to leave it as in the exponent, that 96 on the right there and the 64 on the bottom, you can. Whatever you want. And by the way, you can put that 3 in front of the ln. Did I rewrite it? I did. Okay, so because it's timesing by 3. It's timesing by 3 over 1. So we can just, to make it easier to look at and type in, you can put the 3 in front of the ln. And if you didn't simplify the fraction, we could have stuck this 96 in front of the ln to have 96 ln on top, all over 64, similar to this that's reduced. It's up to you. So 70.71 grams is what two of you got. So there's the drawn out, rounded to whatever places, and then hundredth is 2 places. So, yep, perfect. After 4 days, there will be approximately 70.71 grams remaining. On your TGA, make sure you give me a units. Don't just put 70.71. I'll be like, is 70.71 miles? Is it 70.71 cubic feet? Gallons, liters, kilograms? So yeah, just don't forget your units. All right. Let's try a growth. Again, it's done the same way. It's still the same equation. And if you notice, so if we typed in the K value, so radioactive decay, if you typed in this K value, you hit enter. And if you typed in this K value, hit enter, your K values for radioactive decay will always be negative. If your K value, if you type it in, is not negative, then you did something wrong, because decay should have a negative K value. And what do you think growth is going to have? What kind of K value? Yeah, it's going to have positive K value. I just thought I'd point that out. All right, let's do this problem. We got 2 more problems, this one and one more. In a certain culture, the number of bacteria. Hey, I'm sorry, hang on 1 second. I thought it was Stride. Trying to fix my work computer. They call it the worst times. Anyway, in a certain culture, the number of bacteria grows exponentially. If 1,000 bacteria are present initially and the amount double in 12 minutes, how long will it take before there will be 1,000,000 bacteria present? Round to the nearest minute. Okay, what's our starting amount? 1,000. So, and by the way, in part one, they're always going to give you a starting amount, and then in some form or another, they will give you the ending amount and it time to get to that ending amount. Just keep that in mind. So, what's the ending amount or the time? I know. So what's the time that's given to us? 12 minutes. Okay, so we have 1,000 bacteria, and after 12 minutes, how much bacteria do we have after 12 minutes? What does it tell us? It does say, read it again. And guys, read it out loud to yourself. Use your voice. That way you can hear yourself. Oh. So we got a few people saying 2,000. So why is it 2,000? Doesn't say 2,000, does it? It it says it doubles after 12 minutes. Yeah, look at the wording they use. Yeah, English words. It says the amount doubles in 12 minutes. Oh, so in 12 minutes we have double the amount. So double 1,000, you get 2,000. So these problems, it might be easier to start with your initial amount and then say, all right, how much time has passed to get to an ending amount? So maybe it'd be good to kind of reorder these. We put 12 here, 12 minutes, and then we ask ourselves, okay, we got 1,000 in 12 minutes. How much do we have now? And it says it doubles. So 1,000 times 2 is 2,000. This 1,000,000. It says how long will it take before there will be 1,000,000 bacteria? This is part two. Part two is we're trying to figure out the time it takes to get to 1,000,000. Again, you got to read them carefully because on your TGA, I may not like if you can't figure out what to put in for part one, I might just tell you to look back at our recordings and make sure you do the examples in the modules for practice. But reading out loud and hearing yourself does help. I promise you. People around you may kind of be wondering what you're doing. All right. What's our starting amount in Sub-Zero for part two? Oh, wait, I'm sorry. We didn't even finish part one yet. All right, so let's plug that stuff in and quickly do it. All right, starting amount. Is it still 1,000? Yeah, it still is. We know our K value already. Which one are we solving for, N or T, for part two? Yeah, we're solving for T. We don't know what that is. That's question mark. So what is the ending amount after unknown time? 1,000,000. All right, so let's go ahead and plug that stuff into our formula. And let's solve it. I'm gonna go. Yeah, it's already kind of late. Divide by 1,000 both sides. 1,000,000 divided by 1,000 is 1,000. Natural log both sides. Move the exponent in front. And then we have natural log of 1,000 equals the natural log of 2 over 12. And then natural log e becomes 1. So we can divide both sides by that fraction, or we can multiply by the reciprocal. I don't remember what I do. What did I do? What did I type? Oh, I took the easy way. I don't know if that's the easy way. If you multiplied by the reciprocal, you would have had 12 over natural log 2, and this is times your natural log 1,000. So 12 times natural log 1,000 equals t. So it's up to you if you want to just divide by the fraction and type this stuff in, or if you want to multiply both sides by the reciprocal to make it look like this. Um, and then just type this in. It's typing this in will get you the same answer. Don't believe me? Do it. All right, and what do we get? What does t equal? And it says round to the nearest minute. Yeah, always make sure you read the end of the question to see how it wants you to round, because every problem is going to be different. Mm-hmm. Yeah, about 2 hours. Yep, 120 minutes. So the cool thing, so it's kind of funny. So one thing that we could do, um, since it does say round to the nearest minute, so obviously a whole number, we can just basically type this right side in and then keep changing t until we get to about 1,000,000. So we would, I would maybe start at 100, then maybe go to like 105, 110, 115, 120, and then try 121, then try 119 and see which one is, I guess, closest. That might be a way to kind of guess and check. I don't know. Ideas, right? Ideas. All right, last one, and then we'll be done. So everyone, get this one started. Give you a moment. All right, what's our starting amount? 500. Um, how much time has passed to get to an ending amount? 2 hours? And after 2 hours, how much do we have? 1,500. Easy. All right, so I trust you, all of you can plug this in and do that work. It's literally the same steps every single time. And once you do, like, I don't know, maybe 5 of each type, you start realizing the pattern and how every problem literally is, the work is like almost the same every single time. Um, they're a lot easier than they appear. All right. We're all good on K value. All right, so part 2, starting amount is, well, it's still going to be the same. K value is, well, we found that already. And then, are we solving for N or solving for T? No, I haven't read this one yet. Let me read it real fast. Cultural bacteria originally numbers 500. After 2 hours, there are 1,500 bacteria. Find how many are present after 6 hours. Round answer to the nearest whole number. All right. So we're solving for N. Yep, good. And then what's our T value for part 2? Yeah, 6 hours. Yeah, one thing you want to make sure is when you read a problem, you want to make sure all the units match, like hours and hours. which they do. Yeah. And if you see like a time unit, like one says days, one says hours, like that last problem a couple ago, you need to convert one of them to the other. All right, everyone, plug that stuff in. Well, that's nice. Already, we just have to do that. What everyone gets. $13,500. All three of you did. That's probably right. 13,500 is correct. So, and again, you can simplify it. Like, looks like I simplified it. Yeah, I sure did. Oh yeah, I don't. Most people probably would just type this in, or 6/2 becomes 3. That's where that 3 came from. I move this 3 back to here to be 3 cubed. I should have actually canceled out E and ln. I should have canceled this out and just dropped down 27 in one step. But it looks like I did 3 cubed first. Then I canceled out E, ln, and 27 came down, and then that times that. But I think most people just probably type that in. Whatever works for you. I don't care. Yeah, no rounding. Right on the dot. All right, everyone. Any questions before we stop? Hopefully this last lesson of this semester wasn't too terrible in the end. All right, guys. Well, thanks for coming. As always, I hope you learned something. I will see all of you tomorrow for our Unit 4 review. All right, everyone, take care.